Hello, my name is Dr. Ruth Walker. I'm going to walk you through how to conduct an independent samples t-test in JASP today. And we are going to use some sample data. The data we're going to be using is from a published research study by Elizabeth Barnes and her colleagues in 2020 to the research journal PLOS ONE. And what they did was they conducted a series of 3 different studies at Arizona State University to understand if bias against Christian students exists in the natural sciences. So you'll look at that data set that I have on the screen here, and you'll notice that it's showing you the percentages of people who are Christian in the general population as well as in the population of people who are scientists. If you look exclusively at the United States, for example, you'll notice that 67% of people in our population would identify or describe themselves as a Christian versus in the scientist population, only 30%. Another study had found that 22% of scientists in the United States said that science has made them much less religious. So there has been a lot of research and data out there to suggest that maybe something is happening in the natural sciences that we don't have a lot of students in the natural sciences who identify or describe themselves as a Christian. So to study this and understand this further, Elizabeth Barnes and her colleagues conducted this series of 3 studies. The first study, study 1, wanted to look at, do students perceive a bias? Do students believe there is a bias against Christian students in the natural sciences? And so you can see here from what's displayed on the chart, we've got a couple different items here. Let's just look at the first one, for example. It says discrimination against Christians is not a problem in science. And if you look at the column all the way to the right, highlighted and encircled in red, we can see the percentage of students who participated in the survey who disagreed, and 52% disagreed, meaning that 52% or the majority of students who participated in the study did perceive that there is discrimination or discrimination against Christian students in the natural sciences is a problem. That's not where they stopped. So that was the first study, and that was to see, do people believe or perceive that there's a problem? The next 2 studies were experimental study designs that were designed to see, well, okay, so students perceive a bias, but is there actually a bias by faculty in the natural sciences? So what we did, and what they did rather, is we're going to look at study 3. So study 2 is incredibly interesting data. It doesn't lend itself to us running an independent samples t-test. So we're going to look at study 3 instead. For study 3, in their experimental design, they had 2 different conditions. So in the first condition, they had an evangelical Christian condition. And so in this condition, the student applicant, in this case, it was a fake graduate student applicant for a graduate program. And what they did in their application was signal that they were an evangelical Christian. And how that was done by the researchers who designed the study is they had the student application include a description of a mission trip they took for Campus Crusade for Christ. And one of their recommendation letters was from a mentor with that ministry. In the control condition, that graduate student application also included a service trip, so a similar type of trip. It was for the United Nations Children's Fund, so no religious affiliation. And they also included a recommendation letter from a mentor with UNICEF. Again, they were trying to keep everything else equal, so like GPA and GRE scores and everything else was held constant or the same between those 2 conditions. The only difference was the one student had taken a missions trip and the other one had taken a service trip with the United Nations. So what they wanted to see is if we give these 2 applications, we randomly assign them to faculty members in biology, are they going to rate them differently? Specifically, they asked them to rate them on likability, on hireability, and on competence. So let's take a look at our null hypotheses. So for our first one, are there differences in average biology faculty likability ratings of a mock graduate student applicant between the faculty who are randomly assigned to the evangelical Christian condition or the control condition? And you can see our null hypothesis is here. Our null hypothesis is always saying that there are no differences, that there is no effect, that nothing is happening. So in this case, our null hypothesis would say there are no differences in faculty ratings of graduate student likability between the Christian student application and the control student application. And what we're really testing here in an independent measures t-test is the mean of our experimental condition different from the mean of our control condition? That's what we want to see. So for our next two hypotheses and questions, they're going to be the same. It's just a different word. So instead of likability, now we're going to be looking at hireability. So are there differences in the average ratings of hireability between that Christian condition and the control condition? And when we're looking at our null hypothesis, again, just the same, we're just switching around a word. So there are no differences in faculty ratings of graduate student hireability between the Christian student application and the control student application. And finally, our last hypothesis is again the same, but we're looking now at competency ratings. So null hypothesis is that there are no differences in faculty ratings of graduate student competency between the Christian student application and the control student application. So one of the things that we have to do when we have a study that has three different dependent variables or outcome variables, and we're working with that same set of participants, is we have to be concerned about our type 1 error rate. So remember, for each comparison that we have a probability of making a mistake, of rejecting a null hypothesis that is actually true, or saying that something's happening when nothing is actually happening with our data set. So one of the things that we do in statistics is when we are making multiple comparisons within the same study is we try to correct for that error. And one of the ways that we could do that is with a Bonferroni correction. So I'm going to introduce this idea to you. If we were only, say our study was only looking at differences in competency, and that was the only comparison that we did. If that's the case, then we wouldn't have to do a Bonferroni correction. But because we're looking at three separate outcomes, that's why we're going to do that. And let me explain why. So our first one, we're looking at differences in likability ratings between these two conditions. So for that particular hypothesis, we have a 5% chance of making a type 1 error if our alpha level is 0.05, which it typically is in psychology and social sciences. For our second research question, are there differences in hireability? Well, with an alpha level of 0.05, we also have a 5% chance of making a type 1 error there. And our last one, the competency ratings, same thing, 5% chance. The issue with this is that when we add that all together, suddenly we have a 15% chance of making a mistake. And in general, we're okay with making a mistake 5% of the time, but making a mistake 15% of the time is a little bit much. And so for that reason, we will do a Bonferroni correction. And what that will do is it'll take that 15% error rate all the way down to 5%. Makes it a much more acceptable level of error. So let's look at what a Bonferroni correction is. When you're making a Bonferroni correction, you can calculate this by hand. It's not that difficult, thankfully. What you're doing is looking at what is going to be your new P critical value, that new alpha level. So if you have an alpha level of 0.05, what's this corrected P value or probability value that you want to look at to determine, are my results significant? Am I going to reject that null hypothesis? So in your numerator, you're going to have your alpha level. In our case, it would be 0.05. And your denominator, K, equals the number of comparisons that you're making. In our case, we had 3 comparisons. So hireability, likability, and competency. So 3 different comparisons to see if there are differences between any of those 3 groups. So our numerator 0.05, our comparisons, the number of comparisons, or K, would be 3. So when we plug that into that formula, you can see our new P critical value is 0.016 repeating. So in this case, if we want to reject our null hypothesis with any of those comparisons, we need to have a probability or value or a significance value that is less than 0.017. So now we are looking for a value that's a little bit lower than 0.05, and that will help us correct for that type 1 error rate being so high. The next thing that we need to do before we even touch our data is to make sure that it meets the assumptions that it needs to meet in order to run the statistical test. So there are 6 different assumptions that our data need to meet before we can run an independent samples t-test. The first one is our independent variable dichotomous and measured at the categorical level. In this case, our independent variable is the graduate student application condition. So we know we have 2 conditions, so it is dichotomous. And we know that it's also measured at the categorical or nominal level. You could either be sorted into the Christian graduate application condition or the control graduate student application condition. So those are that's just a categorical dichotomous variable. So we meet that assumption. Assumption 2 is the dependent variable continuous. In this case, we have 3 different dependent variables. We have likability, hireability, and competency. And the authors measured each of those with 4 different items each on a 7-point Likert scale. So for this one, it was measured at the interval level or the continuous level. So we meet that assumption for this too. Number 3, are the samples independent? What this means is, are the people who were randomly assigned to the Christian graduate application condition separate and unique from the faculty members that were randomly assigned to the control condition? In this case, we also meet that assumption. Their faculty members were not assigned to both groups. They were not matched in any way. They are completely independent. The next 3 assumptions we have to check actually in JASP. Number 4 is our dependent variable normally distributed for each group of the independent variable. We're going to check to see if our data are normally distributed in JASP. And the next one, number 5, are there outliers in our sample? We'll check that in JASP as well. And number 6, are there homogeneity of variances? So for that, we'll look at the Levine's test, and we'll do that in JASP. So for the next step, we have to move into JASP to work with our data. So the data set you're going to be working with, it's labeled Independent T Practice Data. It has the Barnes et al. Label there. You can get the link to access the data file in the video description. So while you do that, I am going to go ahead and share my screen so you can see my JASP. And we can walk through those steps together. So with JASP, we're going to be doing a couple different things. So the first thing that we need to do is we need to check some of those assumptions. So we need to check, are our data normally distributed? And as well, do we have any outliers in our data set? And then finally, do we have homogeneity of variances? So one of the first things that I like to do when I am working with data is to change some of the variable labels to make interpretation of the results a little bit easier. So in this case, I'm going to click on condition up here. When you hover over it, you'll see the little icon will come up. It'll say, click here to change labels. So I'm going to click there. So when we click on that, we can see the value 0 and 1, and we can see the label 0 and 1. I'm going to change this. So 0, I'm going to type in Christian student condition. And for 1, I am going to type in control condition. This will make life a little bit simpler in terms of reading the results and understanding what they mean. Once you have those labels changed, you can just click the X there, and now you can see these values have been changed here in our column. The next step is we're going to go over here to descriptives. So this is where we're going to get information on whether or not we have outliers in our data set and whether or not our data are normally distributed. So the first thing you want to do is move your independent variable, which is condition, down here to this split box. And then the next step is you want to move your dependent variable, or in this case, we have 3, so dependent variables, over here to our variables box. So I am just going to click on the 3 of those and move those there. So we have a couple more things that we need to do. So if you click down here on plots, you can see we have some different options and that we can click here to get more information. I'm going to click here on box plots, and I'm going to ask JASP to label the outliers for me. That way I can see, do I have outliers in my data set? There are some other plots here that you could click on if you wanted to look at histogram and other types of things. They can give you valuable information and give you a better idea about whether or not your data are normally distributed and show you the spread of your data in your data set. For this example, I'm going to try to keep it simple, and I'm going to show you a way of checking for normality just by looking at skewness and kurtosis statistics. So I've got our box plots that'll give us the answer to our 5th assumption, do we have outliers? I'm going to go ahead and close this now. I'm going to click on statistics next. And down here, you'll also have other options. You can see mean is clicked, standard deviation, minimum, maximum values. If you wanted to look at for quartiles, you could. What I'm going to click on is skewness and kurtosis. That's going to give us information about normality and how our dependent variables are distributed. You could also click on the Shapiro-Wilk test, but I'll tell you that when you have larger sample sizes, it tends to be, because it's a p-value based test, it tends to be fairly sensitive, and it doesn't always give you accurate information about whether your data are normally distributed or not. So I like to stick to the skewness and kurtosis values. So knowing that I have that, I'm going to click on this arrow so I can make our results output a little bit larger so we can look at that. So you can see up here, we have competence, hireability, and likability. And we can see the different conditions. So Christian student condition here, control condition. So we are going to be looking at 3 different sets of skewness statistics and 3 different sets of kurtosis statistics for each of our dependent variables. Also, when you're looking at skewness and kurtosis statistics, one of the things that you want to pay attention to is, are they within the acceptable range? And one general guide for that is, are they within -2 and a +2? Some people will have more stricter guidelines for that they will look for values that are within -1 to +1. So you do have to speak with your instructor or your advisor, or look at your discipline and see what is acceptable in your discipline. But I am teaching in psychology, and in general, we try to stick to -2 and +2. But again, there's some variability there between people and between researchers. So looking at our skewness statistics, I'm just going to go down this line and make sure all these values are between -2 and +2. So we have -0.406, -0.460. Those are both within -2 and +2, -0.349, -0.708. That's also within -2 and +2. -0.366, -0.345. Again, also great within -2 and +2. So let's go down to kurtosis. So kurtosis, 0.309, -0.317. Those look good. -0.632, -0.257. Those also look good. And then last set, 0.363, -0.530. Those all look good. So all of our skewness and kurtosis values are all within the -2 and the +2 that we're looking for. So we are good to go with that. Our next assumption was, do we have outliers in our data set? So for that, we're just going to look at the box plots. It's a fairly simple way of gauging whether or not we have outliers. Typically, if we have an outlier issue, we will see a lot of times issues with our kurtosis values, which we didn't run into in this data set. So our data are normally distributed. They're not skewed to one side or the other, and they don't have a lot of kurtosis, when they're not all skinny and clumped around the middle there. But when we look down here, JASP labels our outliers for us. And you can see here in this is for our competency dependent variable. I'm just going to make this a little bigger so we can take a good look at that. You can see we have 1, 2, 3, 4, 5, 6 outliers down there below the whiskers. So when you're looking at a box plot, you want to look between this lower whisker and this upper whisker, and you don't want anything outside of that. This is our median value, this bold darker line in between, and these are the quartiles that we have for our distribution. So values that are outside of those whiskers, in this case, in the competency ratings and the Christian student condition, we had some faculty members that gave that student fairly low ratings of competency that didn't kind of hang out with the rest of the faculty ratings. So participant 210, participant 179, 172, 73, 30, and 25 all had fairly low ratings of competency in the Christian student condition. If we look over here at the control condition, that all looks good, no outliers. Now, the authors in this study didn't mention anything about outliers. When you have outliers, you have to decide, am I going to keep them? Am I going to delete them? Is the data real? A lot of times you want to go back and double check your data entry, or if you're working with machines, their calibrations, those types of things to make sure it's accurate. So in this case, the authors didn't mention in the article doing anything about the outliers. Sometimes what researchers might do is run the data with and without the outliers to see if there's a difference. Many of these tests, particularly when you have fairly large sample sizes, are pretty robust, meaning they can handle some of that non-normality and it's all right. So a lot of different ways that you can deal with this. Delete the outliers, see if there's any difference. Usually for me, if there's no difference, I try to keep them in. But that's, again, that varies by researcher. So we know we have some outliers hanging out here in our competency condition. Let's look at our other two dependent variables. So higher ability, when we look at this box plot, there are no outliers labeled in either our Christian student or our control condition. And then this last dependent variable, likability, we can see one outlier hanging out here in our control condition. And you can see it is fairly close to that whisker there. So I wouldn't be too concerned about it myself. Although I am a little concerned that we have 6 outliers here and our dependent variable for competency. So moving forward, we've checked, we have a fairly normal distribution, skewness and kurtosis values all look great. Next step, we looked at our box plots. We know that we have some outliers in our competency condition and we have one in our likability condition. If you were writing this up in APA format, you would just want to make sure to mention that. Say skewness and kurtosis values were all within acceptable ranges of -2 and +2. And when we looked at the box plots for outliers, there were 6 outliers in our dependent variable competency and 1 for likability. So next step is actually getting to running a t-test. So let's go up here. We're just going to click on the t-test button. And when you go down, it is nicely labeled for us in JASP. So thank you for making it so simple. Independent samples t-test. Let's click on that. When we're here, we need to move our variables into the right boxes. So our grouping variable down here, this is our independent variable. So condition is going to get highlighted and moved over there to that grouping variable box. And next, we're going to move likability, hireability, and competence over here to our variables box. That's where our dependent variables go. And if we look down here, we have some options that we can check here. So under tests, the student t-test, that's our default t-test. You can also see Welch and Mann-Whitney. We're actually going to click on Welch. I do that automatically. And the reason for that is because if we don't meet our homogeneity of variances, if we don't meet that assumption, then we can interpret a Welch t-test instead. So I just check it to make sure I have the output there in case I need it. And then you can see additional statistics. You can get confidence intervals, effect sizes. We're going to look at effect sizes. Specifically, we're going to look at the Cohen's d effect size. I also click on descriptives and descriptive plots. That gives us an idea of the means for our different groups, and it helps us see visually what's going on with our data if we have significance there. And then you can see over here assumption checks. So normality, we've already checked normality with skewness and kurtosis, so we don't need to check that, but we do need to check that sixth assumption, equality of variances. So I'm going to check that box as well. So depending on who you're working with and the journal that you're planning on submitting to, you may want additional information here. You may need to run additional tests. It just all depends, but for the students that I tend to have in my statistics classes, this is the information that I ask them to know. So once I have everything clicked, I'm just going to click on this arrow over here so I can make my results larger and we can look at those. So first things first, let's look at our assumption checks. We're going to look here at our test of equality of variances, the Levine's test. For this test, we want our p-value to be greater than 0.05. If our p-value is less than 0.05, that means that our test is significant and we do not meet this assumption. So if we look here for competence, you can see, our p-value is 0.605. That is larger than 0.05. This means that for competence, we do meet the assumption and we do have equality of variances. So next one, hireability. Our p-value here is 0.072. That is also larger than 0.05. So we also have equality of variance for hireability, and that is good. So the last one is likability. You can see here our p-value is 0.004. Bummer, it is less than 0.05, so we don't meet the assumption. We don't have equality of variances for our dependent variable of likability. It's not the end of the world. It's okay. That's why we clicked that Welch box. So what this means is for competence and hireability, we have equality of variances. So we are going to interpret the student's t-test. For likability, we don't have equality of variances, so we're going to interpret the Welch t-test instead. So we come up here, let's look at competence. This is our independent samples t-test box. This is where we're going to determine, are we going to reject our null hypotheses or fail to reject our null hypotheses? So for our dependent variable competence, let's look at that. We're going to interpret the student t-test because we had equality of variance. You can see here this negative 2.771, that's our t statistic. 259, that's our degrees of freedom. And then our p-value here is 0.006. And then we have a Cohen's d value of negative 0.343. So a lot of information in a small space here. So with this p-value, what we're looking at to determine, are we going to reject this null hypothesis or fail to reject the null hypothesis? We want to know, is it less than 0.05? In this case, 0.006 is less than 0.05. So for this hypothesis, for looking at, are there mean differences in faculty ratings of competency between the Christian student condition and the control condition? The answer is yes. Our p-value is less than 0.05, so we are going to reject that null hypothesis. And also we can look here at our Cohen's d value, 0.343. Cohen's d values, a 0.2 is small, a 0.5 is medium or moderate, and a 0.8 is large. So here, a value of 0.343, that would be a small effect size. So next variable, our next dependent variable is hireability. So we did have equality of variances with hireability. So we're going to look at and interpret the student t-test here. So you can see our t-statistic, our t-value is negative 3.333. Remember, anytime you're reporting these things in APA format, you want to round to 2 decimal points. So degrees of freedom, again, is 259. And then our p-value here is less than 0.001. Less than 0.001 is absolutely less than our alpha level of 0.05, or let's thinking back, our Bonferroni correction, we have to actually have a p-value that's less than 0.017, right? And in this case, that's absolutely less than that. So we're also going to reject this null hypothesis and say that there was differences in the faculty ratings of student hireability between the Christian student condition and the control condition. And our Cohen's d value was negative 0.413. And knowing that 0.5, we have to get at least 0.5 to have a medium or a moderate effect. This is, again, a small effect size. And just wanted to go back up here to this competency rating. Our p-value here of 0.006 is also less than that Bonferroni correction p critical value of 0.017. So we would still reject this null hypothesis, even making that correction there. So our last dependent variable is likability. Likability is the one that does not have equality of variances. Our Levine's test was significant. Our p-value there was less than 0.05, so not a big deal. We're just going to interpret this light gray line here and look at the Welch t-test instead. So our t-statistic here is negative 5.085, our degrees of freedom. Degrees of freedom always look a little wonky with the Welch t-test or even the Welch ANOVA. So you can see here it's 238.676. And then our p-value here is less than 0.001. So again, this is less than our corrected p-value of 0.0167. So we are going to reject our null hypothesis, and we're going to conclude that there is a difference in faculty ratings of student likability between the Christian student condition and the control condition. And looking at our Cohen's d value for our effect size, we have a negative 0.631. This is above that cutoff of 0.5 for a medium or moderate effect. So we have a medium effect size for faculty ratings of likability. So we've gone through, we've checked all of our assumptions, we've looked at our p-values and our Cohen's d values for all 3 of our dependent variables. We know that we are rejecting all 3 null hypotheses. There are differences in the faculty ratings of graduate student competency, hireability, and likability between those 2 conditions. What we don't know is what those differences look like. So there are a couple different ways that you can make that determination, which one was higher than the other. So you can look here at your t-statistic. You can see that when we went back to change those values in that condition column, that our Christian student condition was a 0 and our control condition was a 1. And you could just know that that is having that negative t-value is showing you what we're seeing down here. So this is why I like to click the descriptive plots, because if you're a visual person like me, you like to look at this because it gives you a good idea of what's happening. This is also why I like to label those values. So looking here at competency ratings, we have the Christian student condition and the control condition. pretty clear that the control condition is being rated higher in competence. If we go over here to the higher ability condition, we have the Christian student condition, the control condition. Pretty clear again that that control condition is being rated higher in likability by these faculty members. And in the last condition, likability ratings, also clear that the control condition has higher ratings of likability than the Christian student condition. Another way you can get the same information is just looking here in this descriptives box. So you can see here for competency, we have the Christian student condition. It gives us our n size in that condition, our mean, our standard deviation, and the control conditions right below it. So you can see the mean for the competency ratings for the Christian student condition is 4.682. The mean level of competency for faculty ratings in the control condition is 5.090. So that is higher. So you can also just look at these means here, and that'll give you the same information as what we see down here. When you're reporting this information in APA format, you'll want to have the means and the standard deviations for each of these groups, so you can report that in your results section. You'll also need to report your Levine's test results. You'll also need to report your T statistic, degrees of freedom, p-value, Cohen's d. All of that information is information that you're going to write up and put in APA format. So if you need information about how to do that and how to go through those steps, you can look at the guide. That there's a link to that in the video description. It'll walk you through these steps as well with pictures, but it'll also include a description of how do we write these results up in APA format and what does that look like when we do that. So you can get that information just by clicking on that JASP guide, and it will give you how to write this up in APA format and that information. Thank you so much for tuning in and letting me walk you through this example. If you're interested in learning more about this particular study, I'll have the link to the article that we looked at the data from down in the link. So feel free to click on that and learn more about their study. The researchers had some really interesting ideas about why they had these ratings. Why were faculty members in biology more likely to rate students who were in the control condition versus this Christian student condition higher in terms of competency, higher ability, and likability? They thought that perhaps it may be just due to stereotypes about students who are evangelical Christians, and there has been a history in some of those groups, in the fundamentalist Christian groups and evangelical Christian groups, to be associated with movements against evolution, for example, and for the implementation and teaching of creationism in schools. And so it may be somewhat related to that. What these three studies did is show that sometimes there are differences in terms of student perceptions of bias, and sometimes there are differences in terms of faculty ratings of students. But to get a clear picture of their overall study results, you also need to look at study 2, because they had some different results when they conducted their study for study 2. So really, to get the full picture, you have to look at all three of the studies together and the results. And we just looked at a piece of one of the studies for this particular example. So thank you for joining me for this example. You can see the video descriptions for additional information and links to additional supplemental materials that might be helpful for you.